Okay, so back again. Um, in this episode, I am welding the support mast for the wind turbine, and because I'm stubborn, and because hiring somebody to weld this cost about the same as getting a TIG welder, I went ahead and purchased a small TIG welder. Um, And I've done some welding in the past, but nothing spectacular. Mostly oxyacetylene, which is a totally different kettle of fish than TIG welding. But essentially, the turbine came with a base plate of common steel that needed to be welded to a 1-inch diameter tube of stainless steel. And so here I'm fitting or manufacturing a spacer to fit the gap in between the pre-drilled hole and the diameter of the stainless steel tube. And I just cut a small piece off of an extra piece and cut it down the middle, and it actually worked perfectly. There's a bit of a gap, but it gives it stability. Now, what I did is I brought the TIG welder on and plugged it into the generator, but it just didn't produce enough power, and there were sparks all over the boat, which was just not a safe operation. So I ended up going to a friend's house and plugging in, which I didn't film, which I should have, but worked out quite well, and not pretty, as you'll see later, but I got the pieces with a good bond top and bottom. Um, the more critical thing that I'm worried about is the fact that the mast is only 1 inch wide and thin-walled, or thinner-walled than I'd like it to be, and I'm concerned that eventually the mast will bend. So it's not particularly the weld at the top, although that is a concern, um, but secondary to other issues. And so here I'm going to go through the whole process where I installed the spacer, I welded it and bolted it together and installed the wiring. So here we go. So at this point, I'm testing the weld, and as you can see, it essentially breaks apart. And so one of the major things that I didn't do properly was to clean the surfaces, and essentially they need to be surgically cleaned using acetone, which I did when I actually welded it. And so here you can see I test the weld and break it apart quite easily. So you need to actually melt the surfaces to create that bond, and I just wasn't getting enough voltage from the generator. It may have been good for small repairs or something like that, but in order to get that type of weld, I needed full 110 volt power. Yeah, so there you go. Okay, so this is the post weld assembly, and here I'm fitting together an insert so that I can put a base through the hull, or through the deck, sorry, and attach it to the aft lazarette bulkhead, and then insert the wiring into that base, and then insert the mast over top of the sleeve, and so it'll be able to stand on that. And it'll provide me with the option to remove the fan for servicing at a later date. At this point here, I actually found an existing piece of 1-inch tube that fit the sleeve much better. Right, and so once it was welded, bolted together, I assembled it on deck, and you can see here the really atrocious welding job. Um, it's finicky because it's a thin-walled tube, and I just do not have the practice. But I filed it down. It was actually welded on the flanged edges at the very top and the sides, so it's secure. Touch wood. Here, got the lead coming from the tower. 3 alternating currents, and now I need to attach or put on the shrink wrap before making any connection. I bought 2 controllers and one came with it, which is handy. And put it on this end. When you're putting the shrink wrap on, you want to make sure that it's far enough away from the joint that it doesn't get melted. Otherwise, it's impossible to slide over the joint. So, for marine work, I find having this butane torch is adequate. It's not precise, but it requires no electricity. And it works in an emergency, if you're on the top of the mast, trying to do some circuitry up there, you can use the torch. Okay, so we've got our flex paste. I've got my alligator clips as heat sinks. And we're just going to torch-a-roo. Try not to burn the wood. Okay, so you want to heat up the joint enough that it'll melt the solder. You don't want to just melt the solder using the torch. And it should be nice and shiny silver for a good joint. Okay, that's number 1. So I splay these ends out somewhat so that when you connect them, it's just easier to join them. These AC coming out of the junction box or out of the charge controller are all green, and I've just cut up an extension cord, and so they're different colors, but for AC it doesn't matter. There's a rectifier in this charge controller, which is just taking the current from each one and modifying it to DC. Hopefully. All right, China. You'll know from your oxyacetylene welding classes in high school that it's the tip of the blue flame that is the hottest part, but you just want to get it close enough so that it's not spreading ambient heat to the wiring. Okay, that's our second joint. And I'm wiring this up before I put the mast up, because once that turbine starts spinning, it's got a load on it, and I don't want to, I want to have somewhere for this to go. And I'm not actually sure where it's going to go, but I think I'll try to set it up on the starter battery, because currently, once I rewired it, I took off the solar was connected to both the house battery bank, which is made up of 2 deep cycles, and then the
charging, or the cranking battery, and those are mismatched batteries, and so I just disconnected them from the cranking battery, but it means that there's no charge going in. And it's at 12.6, which means it's still a good battery, which is good, but it's not getting any juice. So ideally this is going to go to the cranking battery and then to a dump load, which is going to be either a space heater or a water heater. These, come on, there you go. Okay, I'll coat both so that the joint is actually the joint. Oh, see there, I had the shrink wrap too close and it melted. So I'm gonna have to cut that to get it to go over the joint, which is not good. Okay, so just check your joints. You want to make sure that they're cool before you put the sleeve over. Otherwise the tip of the sleeve just... There you go. Keep that up. And we're we've got our clean sealed cables, and ideally I'd like to be using glue lined cabling, but I don't have it, so SOL.
Right, so now I am just quickly attaching a couple of leads to the loads to the positive and negative side of the battery, and breaking all rules here by just using electrical tape, but this is just to test the circuit to see if I'm actually getting a charge, which will all come apart. I think I may actually have used the wrong size gauge here. So just moving over to the battery compartment and attaching it directly to the positive and negative to the cranking battery. The original setup that was on here was the solar panel was actually charging both the cranking and the house batteries, and it's just the wrong setup. You need a separate charge controller for those two different battery banks, and so I just disconnected it because I didn't want anything to happen to the batteries. Not sure if anything would, but better safe than sorry. So at this point, I'm just going to have the wind turbine charging the cranking battery, and we'll see how it goes. Right, and so here is the through deck, as it were. The base with the sleeve, and at this point it would have really helped to have had two people because I had a difficult time pulling the cable through the bottom of the base below decks while I was lifting this fairly awkward turbine on top of a pole up into position. I've removed any of the cursing that went on here at this point. But get a first mate there on deck if you can for this job. Makes it much easier.
Well, I would say success. Installed the turbine last night, or yesterday, and I don't know if you can see it there. And it has successfully charged the battery from 12.6 to 13.4. That's acceptable. The other bank is on solar, and that's at 13.9, although I believe that's with the solar. And with the controller, it actually, if you can see that red light, it includes a brake, which the other one didn't. And so what that does is it actually stops the fan from spinning, which is great news. So all in all, a success. And got the heater here going for now. It's quite nice with the windows, or the companion way I installed. Just letting in some light and keeping the heat in. And yeah, so on to more wiring. Talk to you later.
So my apologies for the continuing downward spiral in production quality. Initially had great ideas for having music and all these things, but you know, just managing to do the work while filming is quite a chore. The one thing that I do want to make a note of here is that this project is being performed on a budget, and I know a lot of the YouTube channels out there, everybody has all the parts they need and this sort of magic fund for which they can purchase these things, and I don't. And so, you know, for any of you out there who are trying to integrate newer components into an existing system, this will probably be useful for you, because I will be doing piecemeal wiring components as I go. This is not going to be a project where I rip out all the existing wiring and put in all the new fancy stuff. So next we'll be installing the ACR. I'm trying to do everything correctly as I go, but it is not all at once, and so you're going to see things like missed fuses and incorrect processes as I go, and a lot of that is intentional. So bear with me as we go. All right, well, I hope you enjoyed this, and I am enjoying having a third source of energy as a backup. So, till next time.